Good morning, Geometry. Welcome to Wednesday. I am excited to see most of you guys in person tomorrow. It'll actually start feeling like a regular school day. These e-learning days are just funky. So we're going to pick up on the notes where we left off. We did ratios yesterday, so today we're picking up at proportions. Proportion is just setting two ratios equal to each other. And you may not have known that these pieces have special names. The red ones are called the extremes, and the blue ones are called the means. Now, if you write the fraction sideways instead of up and down, you can kind of see why the red ones are the extremes, because they're on the extreme outsides, and the B and the C, the blue ones are more in the middle, so they're more in the average part of the equation. So they have the means and the extremes. Okay, we're going to solve these proportions, and you know that we solve proportions by doing cross multiplication. So we're just going to take x times negative 16 equals 8 times 11. So negative 16x equals 88. And lastly, x equals, pretty sure that's 5, but let me check. Nope. 88 divided by 16 is 5.5. And that would be negative because I divided by negative 16. Okay. Do the same thing for B. Watch your distribution. So I got y equals negative 9.5. Okay. All right, we got two more. You take the means and multiply them together, and take the extremes and multiply them together. 6n plus 24 equals 15n. So I'm going to subtract 6n from both sides and get 9n. So n equals 2.6 repeating, or 2 2/3. All right, and last one. Notice I wrote the 15 first instead of the z plus 2 first. It doesn't matter because it's multiplication, but you guys are more used to distributing that way. So I got 15z plus 30 equals 11z. Watch your z's and your 2's. Minus 22. 4z equals negative 22 plus 30. No, minus 30. It's negative 52. Okay, for that one I got z equals negative 13. All right, so here are some here are some properties of proportion. The cross products property. This is what you've been using forever to solve proportions. You just take and you cross multiply. That's cross product, cross multiply. Okay, and then we have the reciprocal property, which says if you flip them upside down, then they're also going to equal. Now watch, these cross products are going to be the same as they were above. It's still AD times BC, it's just flipped because that doesn't matter in an equation. So that's why that reciprocal property works. It says if you interchange the means of a proportion, then you form another true proportion. So all they did was they flipped the B and the C, And when you cross multiply that, you still get the exact same thing. It's still AD times BC. That's why those are still true. And then the last one, if you add a value to each ratio's denominator, you form another true proportion. Now this one, if I multiply it out, I'm not quite sure what's going to happen. So if I cross product it, yeah, that doesn't really go back to being equal to what the other ones were. And this is not a formula that we use very often. So I'm going to take their word for it that it's going to be equal. Let me do it with real numbers because this is bothering me now. So if I do like 3, so if this one was 3/4 and this one was 6/8, those are equal proportions. And I add the B, so that would be 7/4. And here I add the D, and that would be 14/8. Okay, those are equal proportions too. So it does work. All right, and solve these proportions. You're still going to do it the same way with cross multiply, or maybe you can view, yeah, that I know that that one is going to be times 7, so I can mentally see that it's going to be 21. You still can do the cross multiplication and solve for x. And this one, I can simplify this one a little bit. The second one, they're both multiples of 5, so I could put 2 over 1n, so that's just 2 over n. So then it looks like I'm multiplying both sides by n, but that doesn't really help me. So I'm going to do it the cross multiplication way. So 2n times 5n equals 25 times 10. 10n squared equals 250. Divide both sides by 10. So we get n equals 5. Okay, more proportions. This one I can see real quickly. I'm dividing by 4 in that direction or multiplying by 4 in this direction. So 16 times 4. S is going to be 64. And on this one, gonna have to do some cross multiplication. So y plus 2 times y plus 2, and you're going to have to double distribute that. So that's where you do the FOIL. You do the first, and then the outside, and then the inside, and the last. So you end up with 4 terms. So y squared plus 2y plus 2y plus 4. First terms, outside terms, inside terms, last terms. Or you think double distribution, I distributed the y to everything, and then I distributed the 2 to everything. So y squared plus 4y plus 4 equals 64. Y squared plus 4y. Now, it's been a while since you've done this in algebra. We don't want 60 on the left, we want 0. Sorry, on the right. So I'm actually going to do 4 minus 64. So that expression, y squared plus 4y minus 60, we need to what is that called? Factor. We need to factor that to fit. So I'm looking for 2 numbers that multiply to equal 60, but add to equal 4. Multiply to equal negative 60, but add to equal 4. Okay, so I'm thinking 6 and 10 because they're 4 apart. The question is, which one's negative and which one's positive? It's got to add to equal positive 4, so my 10 is positive and my 6 is negative. Now if I redistributed that, I should end up where I started. So if I do y minus y plus 10, negative 6 times y, negative 6 times 10, so I get y squared plus 4y minus 60. Okay, so it did work. So now, what's the answer? There's two. It's either what fits in the first parentheses to solve for 0, so y minus 6 equals 0, or what fits in the second parentheses to solve for 0. Because as long as one of the groupings is 0, you multiply it by the other one, and your answer is 0. So your two possible answers are positive 6 or negative 10. Okay, last slide, we've got some real world problems here. The ratio of the side lengths of an isosceles triangle is 5 to 5 to 7, and the perimeter is 102. What's the length of the base? So, I always like to draw a picture. So we have a ratio of 5 to 5 to 7. Now that means it could be 5, 5, and 7, or it could be 10, 10, and 14, or it could be 15, 15, and 21. It's 5 times some factor, 7 times some factor. Perimeter is 102. So 5x plus 5x plus 7x equals 102. Because remember, this is the simplified form of a fraction. It might be 5/7, might be 10/21s, it might be 15, oops, I did that wrong, 15/21s. So we don't know what value this fraction was multiplied by before it got reduced. So that's why you put the x in there. So we've got 17x equals 102. X is 6. So that's the value that each of the x's was multiplied by. That's the factor. The length of the base, well, the base is the one that wasn't the leg. The base is the 7x. So the length of that is 42 meters. 6 times the 7. Okay. So we're going to do the same kind of setup for the angle measures in a parallelogram. We're not sure what factor they're multiplied by, but we do know what the angles of a parallelogram are supposed to add up to. They add up to 360 degrees because it's a 4-sided figure. So we've got 2, 4, plus 6, we've got 10x. So x is 36. What is the measure of each angle? So we got 36 times 2, 72 degrees, and 36 times 3. So the 4 angles are 72 and 108. Oops, that's a degree sign. 72, 108. Okay, so now you've got a little bit more knowledge that you can do for your assignment, which is due the day of the quiz, whenever that may be. We're going to continue on this unit. We're not quite done yet. This is just part 1. All right, I'll see you in the Google Meet shortly.